Magnetism is the force exerted by magnets when they attract or repel each other. Magnetism is caused by the motion of electric charges. Natural and manufactured magnets that have magnetic properties all the time are considered permanent magnets. All magnets have two ends, which are commonly referred to as north and south poles. The determining factor of whether a magnet attracts or repels is the pole. Magnets attract when a north pole is introduced to a south pole. If like poles are introduced, either north to north or south to south, the magnets repel. In the activity, I created a DIY toy car which featured with two magnets. A magnet is carried by the car and the other magnet carried by the car operator. The magnetism toy car was able to run because like poles of a magnet repel each other. This is because when the two magnets of like poles are kept facing each other, the lines of forces are in opposite directions. So like poles repel each other. When the unlike poles of a bar magnet face each other, the magnetic lines of force are in the same direction and hence unlike poles attract each other. However, some atoms contain one or more unpaired electrons whose spin can produce a directional magnetic field. The direction of their spin determines the direction of the magnetic field. In electricity and electrochemistry, a battery is any of a class of devices that directly convert chemical energy into electrical energy. Although the term battery technically refers to an assembly of two or more galvanic cells capable of converting energy, it is commonly applied to a single cell of this type. Every battery has a cathode, or positive plate, and an anode, or negative plate. These electrodes must be separated by and are often immersed in electrolyte that permits the passage of ions between the electrodes. In the experiment, we use a battery to touch the screen of the phone instead of our hands, resulting that the battery can really use to touch the screen instead of the hands. The reason for this is that the positive terminal of a battery goes right to the inside of the battery, which isn't a lot of material and has low capacitance. The negative terminal, however, is actually bigger than you think. The entire case of the battery often functions as a negative terminal. So when you grab the battery, you are touching the negative terminal. Basically, the negative terminal completes the circuit between your hand and the front screen, so it works. Magnets come in a variety of shapes and sizes. A magnetic field is always present in permanent magnets. When there is electricity flowing through an electromagnet, it becomes a magnet. When placed in a magnetic field, some objects become magnets. Magnetism is an electromagnet is caused by electricity. However, magnetism comes from within permanent magnets and magnetically attracted substances such as iron and some types of steel. These materials are ferromagnetic. Sewing needles, like the one used in this activity, are typically made of steel. Every atom in a ferromagnetic substance like this acts as a tiny magnet. These magnets are usually oriented in different directions. A powerful magnet nearby, on the other hand, can cause all the atoms to line up in the same direction, combining all those mini magnets into one large one. There are other methods for rearranging atoms in iron or steel. When the needle is heated above about 770 degrees Celsius, the atoms in the metal change pattern. The iron atoms cannot line up to form a magnet in this new pattern, and it is no longer attracted to magnetic fields, and that is the reason why it drops.